Okay, so let's read the problem first. It says a 16.1 sample of gas at 23 degrees Celsius is heated to 76 degrees Celsius, and it's asking you what is the new volume of the same gas sample when kept at constant pressure. So the way you guys, I want you to solve this is you're gonna go through the problem and read off or label every value that they're giving you, okay? So the first value that they're giving you is 16.1 liters. What is that?
Volume.
It's a volume. So I'm gonna label it as V, okay? Then it says 23 degrees Celsius. What is that?
Temperature.
It's a temperature. It's heated to 76 degrees Celsius. What is that?
Temperature. Another temperature.
It's another temperature. So I'm gonna go back here and I'm gonna label it T1, and this one I'm gonna label it T2 because that's the second temperature they've given me. Okay? Then it says, what is the new volume? That is what the question is asking me, and for a new volume. So this is gonna become my V2, this is gonna become my V1. Okay? What is the new volume of the same gas? We know we're dealing with the same gas. Okay, when kept at constant pressure. So, which one of the three calculation laws are we going to use? 1, 2, or 3? Dalton's law, ideal law, or combined law?
Combined.
Combined. Why combined?
Because you have two volumes and two.
I have two volumes and two temperatures. What are the rules of combined law? It says cross out variables that are held constant. What are my variables that are the question is telling me is being held constant?
What's the E?
So I'm gonna write combined law right here real quick. V2 over N2 T2. Okay. So what is the constant variable that's being held constant?
Pressure.
Pressure, right? So combined law tells me that I can cross out anything that's being held constant. Okay, I'm gonna change the color real quick. White. So I crossed those out. So now I have V1, V2, T1, and I'm looking, and I have a T2. I'm looking for V2, right?
Yeah.
So, what is the other variable that we don't know about? N. What is N?
Number of moles.
Number of moles. Is the number of moles gonna change if I'm dealing with the same gas sample?
Nope.
No, right? So, is it being held constant?
No.
Yes. So I can cross those two out. So I'm gonna rewrite my new equation right here, right next to it. It's gonna be V1 over T1 equals to V2 over T2. Okay? So now I'm gonna start plugging it in. What's my V1? 16.1 liters.
Wait, you got to convert the Celsius to.
Thank you. So my temperature, I was gonna ask that next. My temperature's in Celsius. What do I need to do?
Back up to Kelvin.
I need to convert it to Kelvin. So I'm gonna do that down here. My T1, it's actually what? 23 degrees Celsius plus 273.
296.
So it's 296 Kelvin. Okay? My T2, it's equal to
322.
76 degrees Celsius plus 273, which is equal to what?
349.
349 Kelvin. Okay? So, these are my two temperatures. I'm gonna go back to orange. I'm gonna keep plugging it in. My first T1 is what? 296. And that's equal to V2. What is V2?
Oh, we don't know.
We don't know, so I'm gonna put V2, or also known as X, right?
Yeah.
That way we can solve for X, over
349.
349. So this is when algebra 1 comes in. You gotta cross multiply. So I'm gonna cross multiply these two guys. I'm not gonna cross multiply here because that's already a variable, okay? I want it by itself. So I'm just gonna leave that number there. So when I cross multiply this, what do I get? What's 16.1 times 349?
5618.9.
5618.9 over 296 equals V2. So what is my V2?
18.98.
18.98 liters. All right? Okay. Any questions on this? No? So what did we do first? We went over the problem, we read it, we labeled every single one of the units or values that they're giving us. Okay? Then we looked at the three laws. We looked at what variables we had or what values we had, and we're gonna choose which one we're gonna use or which one's more convenient to use. If I'm dealing with all pressures, then I'm gonna use Dalton's law. If I'm dealing with one value of each, I'm gonna use ideal law, which is equal to PV equals nRT. And if I'm dealing with multiple things of something, then I'm gonna use the combined law, okay? Yes.
Everything's at a constant, we can just like exit out.
Yes, if it's constant or being held constant or not mentioned at all on the problem, you can cross it out. Okay, if I don't talk about moles, then imagine it's not there. Okay? So you cross it out. All right. The next problem. What does it say? It says, what is the total pressure in a closed container of a gas mixture containing 320 millimeters of mercury? What is this?
That's
So the gas-
the conversion to
What is this?
320.
What's 320 millimeters of mercury? What type of unit, what type of measurement is it? It's a pressure. Okay? How about this?
Another.
Another pressure.
That's another pressure. So I'm gonna label this P2. I'm gonna go back and label this P1. What is this?
Another pressure.
It's another pressure. So this is gonna be P3 now. And what is the question asking me?
What's the total pressure?
Total pressure. So I'm gonna label it as P total or P tot. Okay? So what formula am I gonna use? Dalton's law? I'm gonna use Dalton's law. Very good. So P total equals to the sum of all pressures. P1 plus P2 plus P3.
Basically, we just add that.
Okay? So, yes, now all I'm gonna do is plug in the numbers. So P total, it's equal to 320 plus 200 plus 100. 620 what?
Mercury.
Millimeters of mercury. Don't forget units, guys. Okay? Don't forget units. Any questions on this one? It's simple addition. We're not cross multiplying.
So
Leandro, wake up.
I got 10.
Okay,
Ready.
next problem. It says, when the temperature of the cylinder with 685 liters of helium gas is held at 621 Kelvin, the pressure is 1,890 kilopascals. How many moles? So it's asking me for what?
Oh.
Moles. How many moles of gas does the cylinder contain? So let's go through it and label everything. What is this?
Volume.
A volume. What is this?
Temperature.
A temperature. What is this?
Pressure.
A pressure. What law am I gonna use?
Ideal.
Ideal gas law. That says PV equals nRT. If you look back at your notes, there's 3 R's that we can use, right? That's it. Gas constant. There's 3 R's. One for each unit of pressure. What unit of pressure do we need to use on this one?
KPA.
Kilopascals. So what's gonna be our R?
The most.
8.31 liters times kPa over moles times Kelvin. Okay? So now, all we need to do is do what? Plug in the numbers. What's my pressure?
1,000.
1,890. What's my volume? 685. That's equal to the number of moles, which is what we're looking for. What did we say we were gonna use for R? 8.31. I'm gonna leave the units out because it's too much writing. But you know that it's liters times kilopascals over moles times Kelvin. And temperature, what's my temperature?
621.
No.
Do I need to convert to anything?
No.
No, right, it's already at Kelvin. So I don't need to worry about that. So I'm just gonna plug in 621. Okay?
Where's the 8.31?
That's the R, the gas constant. So 1890 times 685, that's a big number, right? So you get 12,94650 equals to 8.31 times 621, 5160.51 N. So for N, all you do is divide both sides by 5,160.51.
Just the 5 oscillate side. That gives you.
N equals 250.88.
87.
What? 250.88 what? Moles.
Yes, sir.
So this is my answer. All right? Any questions on this one? All right. Moving on to the next one. It says 1.75 liters of a gas is in a flexible container. That might be important, so I'm gonna underline that. And I'm also gonna underline the first unit, which is what? A volume, right? 1.75 liters of a gas is in a flexible container at 1.30 ATM of what? Pressure. So I know this is the pressure. Okay? If the pressure in the container is reduced to 9.5 ATM, what is this?
Pressure.
Another pressure. So this is going to be P2. This becomes P1. What is the new volume if the temperature is left unchanged? So what's being held constant? Temperature is being held constant. So what law am I going to use? Dalton's law, ideal law, or combined? Combined. So I'm going to write it right here. P1 V1 over N1 T1 equals P2, sorry, V2 over N2 T2.
Or T2.
Okay? So I'm looking for what?
Volume.
Volume. So it's gonna be V2, this is gonna be V1. What's being held constant?
Temperature.
Temperature. So I can cross those out. What else is being held constant?
Moles.
Number of moles, right? We're talking about the same gas. It's still in the same container, so that's being held constant. Also, they don't mention it at all in the problem, so I'm gonna ignore it. So now I have a new formula. P1V1 equals to P2V2. Now I can start plugging in numbers. Okay? So what's my P1?
1.3 ATM.
1.30. What's my V1? 1.75. That's equal to what? P2, which is 0.950,
And X.
and X or V2. Okay? I like to keep it
Hey, listen,
what I'm looking for.
So, I got a question for you. If they're different pressures, you just have to convert them, right? To be the same pressure.
Yeah, if they're different units, but I'm never gonna do that to you guys. If they're different units, that's a good question. If they're different units, all you need to do is convert from one to the other and make them the same. Okay, so I have 1.3 times 1.75.
2.28.
I get I'm not gonna round until the end. 275 equals to 0.950 V2. So all you do is divide both sides by 0.950.
2.79.
Yeah. I got 2.28 either.
2.4 equals to volume 2. Okay? In this case, I got 2.39, but I rounded up. So that's my new volume. Okay? Any questions on this? All right, moving on to the next problem. Who wants to give it a shot?
I got it. Oh, it takes.
That's all on the board over there. You don't need it. Okay, so it says, what pressure in kilopascals will be exerted
Looking for pressure.
by a 0.45 mole of a gas at 25 degrees Celsius if it is contained in a 0.65 liter cylinder?
Gas at a T.
Temperature, very good.
The container is a point. That's mine.
One. Yes. So you're looking for what?
We're looking for what's the pressure?
In kilopascals. So notice that it's specifying the unit. Okay? So what law are you gonna use? You have one of each.
We're using
Ideal gas law, which is equal to what? Write on the board.
it's equal to
PV equals nRT.
NRT. Alright. My pressure, I'm looking for that.
That's what you're looking for, very good.
P. My volume, I have it somewhere, is a 0.65.
0.65, continue,
I'll tell you today.
continue.
0.65 equals the number of moles. I'm not giving that.
Yes, you are.
Wait, where?
And
0.45. Yeah, I know. I knew that. 0.45. The next part is looking for my R.
R is a constant, right? I gave you all those three values. Which one are you gonna use? The kilopascals The atmosphere or the millimeters of mercury?
Kilopascals.
You're gonna use kilopascals because it says, it's asking you for the pressure in kilopascals.
So it's 8.31.
8.31.
31. And I'm running kind of big, I'm not gonna lie. The last one is my temperature, which is 25 C.
That's wrong.
You need to convert that to Rubik.
You need to convert that to Kelvin. You're always dealing in Kelvin.
I don't know why.
So for like every single question.
Every question you do, you're gonna be doing Kelvin.
Yeah.
Okay? So 25 plus 273, what is it? 298.
And then oh, okay. Alright, so we're just gonna. I think that.
Yeah, next.
5 equals. Hey, somebody do that for me. I'm calculating.
0.45 times 8.31 times. It is not 298. Sorry, it is 1,148.
Coach, I don't know who asked it.
Just leave it there.
Alright,
0.371. 0.371.
0.371. Alright, somebody divide that by 0.65 from real quick.
It is
1,714.4.
That equals 1,714.
0.4. All right,
It's a, that sucks.
that's your answer.
It's
Your pressure is 1,714.4.
divide? Because there's 0.65 on the other side.
Okay.
All right,
You have to write that down.
any questions on this?
No.
Nah, I don't.
Next question. It says, guys, stop talking. It says a mixture of CO2, O2, and N2 has a total pressure of 6.6 atmospheres. Okay, what is this?
Temperature. Pressure.
Total pressure. Okay, so my P total 0.6 ATM. If the pressure of O2 is 0.1 ATM, so that's gonna be my what? P, right? Oh, wow.
That's an R.
What's that? So I'm gonna put that as P1. And N2 is equal to what?
Oh, P2.
So it's my P2. What is the pressure of CO2?
Wait, you forgot the P3, the 0.6.
Oh, oh my God, that's a total.
P total.
Oh, my. Ah.
Okay.
What's wrong with you?
So what is the pressure of CO2? So this is gonna be my P3, okay? So I'm gonna use Dalton's law of partial pressure. So P total equals P1 plus P2 plus P3. I'm gonna start plugging in numbers. P total is 0.6 equals to, what's my P1?
1.1.
0.1 plus 0.3 plus P3. So I'm gonna add these two, so I get 0.4 plus P3 equals to 0.6. When I subtract that, I get that P3 equals to 0.2. I am subtracting here because it's a addition on this side. If it were multiplying, I will be dividing, okay? Alrighty, we're running out of time, so we're not gonna do the rest, but hopefully that helps you guys.